Before we take a deep dive into analyzing polynomial functions, let's make a connection between real zeros, sometimes called real roots, x-intercepts, factors, and real solutions. So recall that if we set a polynomial function equal to 0 and it's factored completely, then we use the zero product property. What does the zero product property say? Well, it says if we have a string of factors, so x minus 1 times x minus 1 times x plus 3, and that equals 0, then one of those factors must be 0. Either this is 0, x minus 1, which would also cause the duplicate x minus 1 to also be 0, or x plus 3 is 0. One of those things has to be 0 for the product to be 0. So we have to solve, in this case, just two one-step algebraic problems. Either x minus 1 equals 0 or x plus 3 equals 0. So this solution would be, well, if x is 1, 1 minus 1 is 0. This solution would be negative 3, because negative 3 plus 3 would equal 0. So the solutions to the equation f of x equals 0 in this example are positive 1 and negative 3. Another name for these are just simply zeros. The factor of x minus 1 gives us the 0, 1. The factor of x plus 3 gives us the 0, negative 3. So graphically, the solutions give us x-intercepts. So as a coordinate pair, the 0 of 1 is written as 1, 0, and the 0 of negative 3 is written as negative 3, 0. So let's summarize these equivalencies. So using the arbitrary letter r for roots, we say r is a solution to the equation f of x equals 0. We could also say r is a real 0 of the polynomial function f. We could say the coordinate pair r0 is an x-intercept of the graph of f. And then we could also say the factor x minus r is the factor of the function f. And finally, f of r has to equal 0. Those are all different ways of communicating the same thing about the value r in its relationship to the function.